we will discuss some formula about electrical machine. It is the video part 2. In part 1, I have already discussed the formula about DC motor and DC generator. If you yet not watch that part, please watch that part from the link given in the I icon. So let's start today's video. In today's video, I will start from transformer. In transformer, you have to remember EMF equation of transformer. EMF equation of transformer is E equal to 4.44 NA phi m. Here E is generated EMF, N is number of turns, F is frequency, and phi m is maximum flux. And then you have to remember transformer ratio. Transformer ratio is denoted by K. K is equal to E2 by E1 equal to N2 by N1 equal to I1 by I2. Here E2 is secondary generated EMF, E1 is primary generated EMF, N2 is secondary number of turns, and N1 is primary number of turns, I1 is primary current, I2 is secondary current. Then you have to remember losses in transformer. Losses in transformer divided by two parts, PCU, copper loss, and iron loss. Copper loss is denoted by PCU. PCU equal to I1 square R1 plus I2 square R2. Here I1 is primary current and R1 is primary resistance, I2 is secondary current, R2 is secondary resistance. Then come to iron loss. Here iron loss divided by two parts, hysteresis loss and eddy current loss. Iron loss equal to hysteresis loss plus eddy current loss. Here PCU or copper loss is variable loss and iron loss is constant loss. Then you have to remember some formula about hysteresis loss and eddy current loss. Hysteresis loss is denoted by pH and eddy current loss is denoted by PE. Hysteresis loss pH equal to kH F Bm to the power x watt. Here x is 10-minute constant and kH is hysteresis constant. F is frequency, Bm is flux density. Here Bm proportional to V by F. If V by F is constant, then the hysteresis loss proportional to F. If V by F is not constant, then hysteresis loss or P is proportional to V to the power 1.6 into F to the power minus 0.6. Then come to eddy current loss. Eddy current loss is denoted by PE. PE equal to KE into F square into Bm square into T square watt. Here T is thickness of lamination. B is flux density. B is proportional to V by F. If V by F is constant, then the eddy current loss is proportional to F square, means frequency square. If V by F is not constant, then PE equal proportional to V square. Then you have to remember the stacking factor. Stacking factor is equal to the net cross-sectional area of core divided by gross cross-sectional area of core. It is less than equal to 1. Then you have to remember calculation of total loss when a fraction of full load is given, that is x. If x as fraction of full load is given, then the total loss equal to W equal to Wi plus x square into WCU. Here Wi is iron loss and WCU is copper loss and x is the fraction. Then you have to remember efficiency at fraction of full load. Percentage efficiency equal to x into V2 I2 cos phi 2 divided by x into V2 I2 cos phi 2 plus Wi plus x square into WCU into 100. Here cos phi 2 is secondary power factor and Wi is iron loss and WCU is copper loss and x is fraction and V2 is secondary voltage and I2 is secondary current. Then you have to remember the condition of maximum efficiency. Condition of maximum efficiency is copper loss equal to iron loss. Next, you have to remember the all-day efficiency. All-day efficiency is equal to kilowatt hour output in 24 hours divided by kilowatt hour output in 24 hours plus kilowatt hour iron loss in 24 hours plus kilowatt hour copper loss in 24 hours into 100. Then you have to remember the voltage regulation. Voltage regulation VR is equal to VNL minus VFL by VFL into 100. Here VNL is no load voltage, VFL is full load voltage. There is another formula of voltage regulation. Voltage regulation VR is equal to I2 R02 into cos phi 2 plus minus I2 X02 into sin phi 2 divided by E2 into 100. Here R02 is resistance referred to secondary side, X02 is inductance referred to secondary side, I2 is secondary current, cos phi 2 is secondary power factor, and E2 is secondary generated voltage. Then you have to remember condition for zero voltage regulation. For zero voltage regulation, tan phi is equal to minus x2 by r2. Here x2 is secondary inductance, r2 is secondary resistance, or cos phi is equal to x pu by z pu equal to x eq divided by z eq leading. Here x pu is per unit inductance and z pu is per unit impedance. X eq is equivalent inductance and Z eq is equivalent impedance. Then you have to remember the condition of maximum voltage regulation. For maximum voltage regulation, tan phi is equal to x2 by r2. x2 is secondary inductance, r2 is secondary impedance. Or cos phi or power factor cos phi is equal to rpu by zpu is equal to req by zeq lagging. Here rpu is per unit resistance, zpu is per unit impedance, req is per unit req is equivalent resistance and zeq is equivalent impedance. Now you have to remember transformer parameter referred to another side. For voltage referred to secondary side is equal to V2 plus V1 into N2 by N1, and voltage referred to primary side is equal to V1 plus V2 into N1 by N2. Next, current. Current referred to secondary side is equal to I2 plus I1 into N1 by N2, and current referred to primary side is equal to I1 plus I2 into N2 by N1. Then impedance referred to secondary side is equal to Z2 plus Z1 into N2 by N1 that whole square. And impedance referred to primary side is equal to Z1 plus Z2 into N1 by N2 that whole square. Then come to auto transformer. In auto transformer, you have to remember the transformation ratio or K. Transformation ratio is equal to V2 by V1 by N2 by N1. Then you have to remember the relation of KVA in auto and two-winding transformer. KVA in auto transformer is denoted by S auto and KVA in two-winding transformer is denoted by S two winding. S auto is equal to 1 divided by 1 minus K into S two winding. Here K is transformation ratio. Then come to inductively transferred kVA in auto transformer is equal to 1 minus K into input kVA. Then you have to remember conductively transferred kVA in auto transformer. Conductively transferred kVA in auto transformer is equal to K into input kVA. Then you have to remember weight of copper in auto transformer is weight of copper in auto transformer is equal to 1 minus K into weight of copper in two-winding transformer. Then you have to remember the saving of copper. The saving of copper in auto transformer is equal to K into weight of copper in two-winding transformer. Then come to induction motor. In induction motor, you have to remember the formula of synchronous speed. Synchronous speed Ns equal to 120 F by P. Here P is number of pole and F is frequency. Then come to the formula of slip. The formula of slip is equal to Ns minus Nr divided by Ns into 100%. Here Ns is synchronous speed, Nr is rotor speed, and Nr by Ns is 1 minus S. Then you have to remember effect of slip in rotor parameter. E2 dash into S into E2. Here E2 dash is rotor voltage, rotor generated voltage, and S is slip, E2 is stator voltage. And F dash equal to S into F. Here F is stator frequency, F dash is rotor frequency, and S is slip. And X2 dash is equal to S into X2. X2 is stator inductance, X2 dash is rotor inductance, and S is slip. Then you have to remember rotor current at running condition. I2 is equal to S into E2 by R2 square into X into X2 that whole square. Here I2 is rotor current, E2 is rotor voltage, R2 is rotor resistance, X2 is rotor impedance. Then you have to remember the torque in induction motor. Torque in induction motor Te is equal to internal mechanical power developed in rotor and rotor speed in mechanical radian per second. Thank you. Thank you for watching. If you like this video, please like, share and subscribe the video. And in next part I will discuss the remaining formula of induction motor and synchronous machine and so on. So the PDF of this video I will be provided in my WhatsApp channel. Thank you again. Thank you for watching and the best of luck for your preparation. Till now, bye. I will come